Boosting TensorFlow model memory efficiency. Imagine training a large neural network or running complex AI models without running out of memory or slowing down your system. Sounds like a challenge, right? Well, there are proven ways to make TensorFlow models use memory smarter and more efficiently. Let's explore how you can do that step by step. First, understanding what TensorFlow uses memory for is key. It stores model weights, activations during training, gradients, and intermediate calculations. When models grow bigger, this can quickly fill up your GPU or CPU memory, especially if resources are limited. One of the most effective methods is mixed precision training. This technique uses both 16-bit and 32-bit floating point numbers. By storing some data in 16-bit format, you cut down on memory use and speed up calculations on compatible graphics processing units. TensorFlow has a built-in mixed precision API that you can enable globally, making your models faster and more memory-friendly without losing much accuracy. Next, adjusting the batch size can help. Smaller batches mean less memory needed per training step. While this might slightly slow down training, it prevents out-of-memory errors and allows you to train larger models on hardware with limited memory. For example, if you usually use a batch size of 100, try reducing it to 50 or 25 and see how your system handles it. Optimizing your data pipeline is also important. Using TensorFlow's prefetching and caching features allows data to load in the background while the model trains. This reduces idle time and makes better use of available memory and processing power. Another powerful technique is model quantization. This process converts model weights and activations from floating point numbers to lower bit integers, like 8-bit integers. Quantization shrinks the model size, reduces memory needs, and speeds up inference, especially on edge devices or mobile phones. Pruning is another tool in your kit. It involves removing less important weights from the model, creating sparsity. Sparse models take up less space and requiring fewer calculations, which boosts efficiency during both training and inference. Managing GPU memory directly can also help. TensorFlow by default pre-allocates most GPU memory, which can be wasteful. Enabling memory growth mode allows TensorFlow to allocate memory incrementally as needed, freeing up resources for other processes and sharing GPU space more effectively. Clearing sessions and checkpoints is a simple but often overlooked step. When you finish training or testing, clearing the TensorFlow session frees up memory. Saving models with checkpoints means you don't need to keep the entire model in memory at once, which saves resources. Finally, profiling tools like the TensorFlow Profiler help you monitor memory use. They show which parts of your model consume the most memory and help you identify bottlenecks or unnecessary operations. Using these insights, you can tweak your architecture or training process to be more efficient. All these techniques combined help you build larger, more complex models like ChatGPT, DALL-E, or Midjourney without overloading your hardware. They also support ethical AI development by reducing energy consumption and hardware costs. When you optimize memory use, you make AI more accessible and sustainable for everyone. In short, boosting TensorFlow model memory efficiency is about reducing precision when possible, managing resources carefully, compressing models, and profiling your work. These steps help you train smarter, faster, and more effectively, even on hardware with limited memory.